everyone. In this video, we are going to work on the MCQ's question practice only on the topic of relation. The first question we have, if we have the ordered pair of this form in a relation for every element of A in a set A, then R is what? So read the question very carefully. This line is very important. It says that if we have for every element such ordered pair in a relation, what type of relation is that? That is reflexive. The next question is the percent on the set of positive integer with the divider relation is not. So here this is the set of positive integer that starts from 1, 2 and continue this, and this relation is divide. We need to check whether this is a totally ordered set or not. So answer in this case is basically A option, while totally ordered set means if we pick two elements from this set of positive integer, let's suppose 5 and 18. We just need to check whether 5 is related with 18 or 18 is related with 5. Right now, neither 5 is related with 18 because 5 doesn't divide 18 as well as 18 does not divide 5. It means these two elements are not comparable. So if each and every element from this one is comparable, then it is called as a totally ordered set. Right now, these two elements are not comparable. It means it is not a totally ordered set. Next we have let R is a relation which contains the ordered pair x, y such that x is less than y on the set of real numbers. Now this relation is what? Whether this is a transitive. How to check this one? So we will check if x, y is a part of a relation and ordered pair y, z is a part of relation. We need to check whether x, z is a part of relation or not. So if it is a part of relation means x is less than y. According to this, y is less than z. Whether we can say that x is less than z from this? Yes. So it means clearly R is transitive. It is not symmetric because if x is less than y, y cannot be less than x. Even it is not reflexive, every element is not less than itself. So answer is option A. Next we have if R is a relation that contains the ordered pair such that x is less than equal to y, and this is a relation on the set of integers, then this relation is what? So for the case number B, R is not transitive. Whether this is true? No. Because this relation is transitive, how we can predict if x is less than equal to y, y is less than equal to z. So this implies x is clearly less than equal to z. So it is a transitive relation. So we can discard the B option. Whether this is a symmetric, if x is less than equal to y, can we say that y is always less than equal to x? No, because we can say that 1 is less than equal to 2, but 2 is not less than equal to 1. So it means it is not symmetric. Now whether this is anti-symmetric? Yes. Anti-symmetric says that we can take the equal type of element, and if x is not is equal to y means if this ordered pair contains different elements, so if xy is a part of relation, this implies reverse should not be there. So if it is a part of relation means x is strictly less than y because we are taking they are not equal. So whether we can say that y is not less than equal to x? Yes. So it means this is a anti-symmetric relation. Next, the relation is defined in this form. Which of the following option is correct? So if R is a reflexive means it contains the ordered pair of this form. So check it whether this is there. A is equal to A plus 1? No. So clearly this is not a reflexive. So for antisymmetric we will check when A is not is equal to B. So if A is not is equal to B, we can say that if it is a part of a relation, then reverse should not be there. Check it whether this is valid. So if it is a part of relation means A is equal to B plus 1 and the reverse is B is equal to A plus 1. Whether this implies this? No, never. So that will never apply this one. So it means it is clearly antisymmetric. Now check for the option C and D. Partially ordered relation means relation is reflexive, antisymmetric and transitive. Right now this is not a reflexive, it means it cannot be the option. Equivalence relation means reflexive, symmetric, transitive. As it is not a reflexive, hence D option is also incorrect. So option only B is correct. Next case, if we have these elements in a set A and these elements in a set B, which one of the following is the subset of Cartesian product? So check it. Cartesian product is defined from A to B. It means the first element will be from the set A and the second element is from the set B. In the first case, Sarjeet and Sanjita. Just we need to check whether this is the part of first one. Yes. Sanjita from the second one. So this can be the possible option. What about this one? Shraddha, this is the part of the set B. But first we need to take the element from the set A. So discard this. Even C is incorrect. So it means only option A is correct. Taking next example, let R is a relation that is defined as we have the ordered pair AB such that both A and B lives in a same country. Pick the incorrect option. So whether this is a reflexive, transitive, antisymmetric or symmetric. So if A and B lives in a same country, we need to take that ordered pair in a relation. So whether this is a reflexive, so A is ordered pair is a part of this relation. Yes, means A and A lives in a same country. That is clearly correct statement, but we need to pick the incorrect one. So discard this. So if A B lives in a same country, whether we can say that B A lives in a same country? Yes, always. So we can discard this option as we need to pick the incorrect one. So if A, B lives in a same country, B and C lives in a same country, can we say that A and C lives in a same country? Always. So it is a transitive. So it means this is a correct option, not incorrect one. So the remaining option is the incorrect statement, that is R is not an antisymmetric relation. So the next question we have, let R1 and R2 are the two equivalence relation on a set, then we need to pick the correct option. So the first case is R1 union R2 is a equivalence relation or R1 intersection R2 is an equivalence relation. In this case, remember that the intersection is always an equivalence relation but not the union. Because when you take the union, maybe transitive property holds or not. So in this case, we can say that option C is correct. Means the statement 2 is true, but the statement 1 is incorrect. Next is, which of the following matrices represents the antisymmetric relation? So antisymmetric relation means diagonal entries can be anything, 1, 0, anything. But if it is there, reverse should not be there. If it is there means if it is a 1, reverse should be 0. And if it is a 1, reverse should be 0 or maybe both are 0. So these are the possibility cases in the antisymmetric. Let's check it. Just collect the ones except the diagonal entries. So here we have 1, its reverse position is this. It contains 1. So both cannot be a 1 at the same time. So it means it is not the antisymmetric. Now for this case, its reverse position is this and it is correct. In this case, its reverse position is this and this is also correct. In this case, the reverse position, correct. In this case, 1 is here and the reverse position is this and it is correct. This is a 1 and here it is a 0. So everything is correct in this case. If it is a 1, reverse is 0. It means this is the antisymmetric relation. Also note that the option C is also representing the antisymmetric relation. Why? Because here we are getting these two ones. its reverse position is this and its reverse position is this. So in this case, two options are correct, B and C. Next question we have, if we have these two relations, find the value of SOR. SOR is basically a composite of relation R and S. So first we will take the element from the R and then from the elements of S. Here 1 is related with 1 and here 1 is related with only 0. So we are getting the ordered pair 1 0. Then 1 is related with 4 and 4 is related with 1. So we are getting the ordered pair 1 1. 2 is related with 3 and 3 is related with 1 and 2. So ultimately 2 1 2 2. 3 is related with 1 and here 1 is related with 0. So 3 0. 3 is related with 4 and 4 is related with 1. So we are getting 3 1. So 6 ordered pair should be there. Let's check it. This is matching to the which option? So 1 0, 1 1, 2 1, 2 2, 3 0, 3 1. Only first option is get matched with this one and hence option A is correct. Taking another case, consider the congruence modulo R this, then this is what? So we have already done congruence modulo M is always forms the equivalency relation because it is a reflexive. Reflexive means ordered pair A is a part of relation. So A is congruent to A mod M. Is the statement is true? Yes. How we are predicting that? If this number is divided by M, whatever the remainder we will get in this case, the same remainder you will get in this case. So it means they are congruent. Similarly, you can go with the symmetric and transitive. I have given the link in a description. The brief overview of this one is given in that video. So this R relation is always an equivalence relation but not the partial order relation and hence option C is correct. Next question we have, consider the relation this, then the number of 0 columns that the matrix of this relation is. So first we will take the relation. As you can observe, we are getting a 3 elements in a first case. So it's like A, B, C. These represents the column. So two elements x, y. So A is related with x, 1. B is related with y, 1. C is related with x, 1. Now here we need to find the number of 0 column. It's not saying that the total number of 0 in this matrix. It says that 0 column. So there exists no 0 column in this case. So answer is D option. Another question is, which of the following is true for the relation represented by this diagram? Whether this is an antisymmetric relation, transitive, reflexive but not transitive, symmetric but not reflexive. For reflexive, we know that every element has a self loop. Right now, element A has a self loop, not B as well as C and D. Clearly, this is not a reflexive. So, we can say that C is incorrect. Now, whether this is a symmetric means exactly two edges but in an opposite direction. So, here we have the two edges, here we have two edges, but from B to D we have edge, but there is no edge from D to B. So, clearly this is not a symmetric relation. Now, what about the antisymmetric? Antisymmetric means exactly one edge between the distinct pair of vertices. Here we have two edges, clearly A option is incorrect. So only one option is left, that is B, hence B is correct.